Hi everyone, we're now going to manipulate vectors and compute with them numerically. Before, when we added vectors, we used ideas like the triangle law, like for displacement, it would look like this, or the parallelogram law, like two cue sticks hitting a pool ball. Draw a parallelogram, here's the sum. I'll put the sum in red actually, or blue. Right? So these were geometric ways of adding vectors, but there are also computational ways of doing it, and it's very straightforward. To add two vectors in component form, you just add corresponding components, add the horizontal components, add the vertical components, same for subtraction. And what about scalar multiplication of a vector, multiplying a vector and a scalar? We distribute. We multiply each component of the vector by the scalar, which makes sense, right? Because let's say this represents a vector v. Okay. What's the deal with 2v? How is 2v different? 2v is twice as long. And you would expect that you would double both the horizontal and the vertical components. Examples work out very cleanly. Let's say the vector v in Cartesian component form is angle brackets 3, 5. Let's say vector w is angle brackets -1, -2. Find 4v minus 2w. Now, instead of trying to get a ruler and trying to lengthen this by a factor of 4 and so forth, let's do it computationally. 4v minus 2w. I'm going to write out what v is and write out what w is. I'm just substituting these in. Right? We distribute in the 4 and distribute in the 2. I actually recommend distributing the -2, because in the end, it would help to frame this in terms of vector addition. So I would actually recommend distributing in the -2 into both these components and turn this into an addition problem, because we're much better at adding than subtracting. We saw this in long division, and we'll see this in matrices later. Anyway, when you multiply a vector by a scalar, you multiply each component by the scalar. So for example, the vector v tells you to walk 3 meters east and 5 meters north. 4v tells you to walk 12 meters east and 20 meters north. Okay? So you multiply each by a factor of 4. So 4v is 12, 20 in angle brackets. Okay. When you distribute in the -2, we get plus -2 times -1 is +2. -2 times -2 is +4. Addition is easier. So if you have a minus sign here, bring in -2 in this case. Addition is easy. 12 plus 2 is 14. 20 plus 4 is 24. You add the corresponding components. 14, 24. That's that. It's a lot easier than trying to draw arrows. Okay. Now, we've talked about multiplying a vector by a scalar. That's when you multiply the scalar in to both components. We can also define scalar division. We can talk about dividing a vector by a scalar, provided that the scalar is not 0, of course. To divide a vector by a scalar, well, when you divide by any non-zero number, you're multiplying by its reciprocal. And again, you can distribute this in. We get a over c, comma, b over c. Basically, to divide a vector by a scalar, you divide each component by the scalar. And by the way, this works in Cartesian, not polar. We're talking about Cartesian components. And this is going to help us because we're going to do this in the next section.